So in this circuit, I use the I here. At first, I will add a while loop here. So in this circuit, I use the I's here as a signal of crankshaft position sensors. That means the speed of the engines raised from 0 to maybe 10,000, as I said. Okay, so do you know that the crankshaft turns 2 revolution, then we have 1 injection. So we have to divide the RPM or the engine speed by 2. So I will choose this numeric divide here, connect I to this, and here we create a constant and set it by 2. Okay. So the engine speed is RPM, but with the injector, the time is short by second, so I will divide it by 60. I will connect this to another numeric divide. I put it here, connect it to here, and create a constant. Constant. Sorry. Here I create a constant and set it by 60. Okay. Then I use a press to input and simulate signal. Put it here. Then is a command table. It's command table. Here you can see the signal type. It has sine, square, triangle, sawtooth, and DCs. Another thing is frequencies, phase, amplitude, and offset, and especially the duty cycle, which is very important to see what happened to the injector. So because the signal injector is where, so then we will use the signal type is where. Then okay. So here we have this. Put it here. So the signal of injector is where. Then I will choose the duty cycle by 50%. So in order to see what happened when the injector works, I create graph indicators. But first I will connect the dot here to the frequencies. Then I create a graph indicator. So now I will create the graph indicator here in order to have a display of indicator. Create graph indicator. I will put it here. So now you can see a graph here. Make it bigger. So this graph is a injector. So now we have this graph, and then you will use the graph to see what happened to the injector. So now I will set the amplitude and the offset of the simulate signal, because the amplitude goes from 0 to 5 voltage, so I will divide it into 2.5 here, and the offset is 2.5. And then okay. As I mentioned before, the engine speed reach 10,000 RPM, then I will stop the circuit. So I add a comparison. So I will add a comparison fader, put it here, and connect it to here. And 1000, add constant. I will add a constant. Sorry. I will connect I will connect I to here, and I will add a constant. I will add a constant here, 10,000. And if the I goes bigger than 10,000, then the circuit will stop. Then the circuit will stop. So then I create a timer to see the circuit work. If we don't have a timer, the circuit will run very fast. So then we cannot see what happened. I create timers here, and I will create constant. It is 10 milliseconds. I will react the constant for timer about 10 milliseconds, and now let's see the injector work. But first we will clean up the diagram to easy to see. So now we will see what happened to the injector. So at first the revolution is low, so that the distance between two square signal is far away from each other. But we will wait. Until the speed engine raise. The speed engine raise. That means the RPM raise, so that the distance between two square signal is shorter, and then we can see more square signal in the indicator screen. So that is how the injector work.